So we're doing question 17. We're doing x cubed plus y cubed over x squared minus y squared. At the top, the numerator is the addition of two cubes, which is a pre-rehearsed formula, which is this pre-rehearsed formula here. Okay. And then on the bottom, so that's the difference of two cubes, the yellow part. The blue part is the difference of two squares, which is written underneath like so. Now, what we can see here is that those brackets are being multiplied by each other because there's nothing in between them. Does that make sense? Okay. And what we're going to do next is we're going to do x plus y cancels with x plus y. Is that all right with you guys? All right. And then there's nothing else that can cancel there because essentially there's no one letter that's been multiplied by everything else on top. And on the bottom, there's no one letter that's been multiplied by everything else as well. So we can't go anywhere. That's it. Done. Stuck. All right. Next one's quite difficult. Next one will take a bit of effort. Number 19. Okay. So just give me a sec. So looking at number 19 here. And number 19 has p minus q squared. Now that's going to take me a bit of effort. I'm going to do p minus q by p minus q by another p minus q. Okay, bit of a trick. I'm electing to take the second and third ones first. Is that okay? I just have a preference for doing it this way, that's all. I'm going to multiply it out. And when I multiply it out, it's going to look like this. P squared minus pq minus another pq plus a q squared. Does everybody know what I did there? The 4 lines. 1, 2, 3, 4. Just multiply the two brackets by each other, okay? Would you be better if going more central? The angle looks terrible. All right, fair enough. All right. And then when I add these together, it's going to be p squared minus 2pq plus q squared. Is that all right? Now, something I told you earlier. I have 2 items in the first bracket. I have 3 items in the second bracket. What does that mean? How many items am I going to have at the end? Huh? Okay. So we don't have 6 items, something's gone wrong. So let's multiply this out. Okay. Now, do you know what? I would multiply it out, but I'm just after seeing something. Did you see something as well? How do I know there's 6 items? 2 in the first bracket, 3 in the second bracket will make 6 items in total. Okay. Now I'm actually not going to multiply it out because I'm just after seeing something. What can I say about the bottom? Difference of 2 squares. So difference of 2 squares is p plus q and yeah, and then yeah, and then that could be my answer there, couldn't it? Yeah, I'm thinking. I'm actually almost thinking I didn't need to even do the. I didn't even need to do the first part really. Like there's nothing wrong with that answer. But what I could have done at the very beginning was just leave it as p minus q cubed, and then just leave it as p plus q and p minus q, and then just get rid of the one of the p minus q's, and then just have it as p minus q to be squared divided by p plus q. Both answers were actually the same. Yeah, that's fair enough. Yeah, no bother. Yes. Yeah. No. Oh, let me show you why. Okay. Let me show you why. Okay. So somebody's wondering about the difference of 2 cubes on top. Okay. Now here's the difference. P cubed. No, it's not because it's minus. P cubed minus q cubed is the preset formula. But what you have written, well, they have written is p minus q to be cubed, which is p minus q multiplied by p minus q multiplied by p. They're different. All right. Let me show you. Let me show you. If you're ever wondering about stuff like this, here's what I suggest. make up numbers for them. So I'll give you an example, all right? What's the difference between 4 plus 3 to be cubed or 4 cubed plus 3 cubed? Are they the same or are they not the same? So they're not the same. So if you put 7 cubed into the calculator, 7 to the power 3 into the calculator, you'll get 343. While this one here is 64 plus 27, which is 81, which is an absolute mile behind it. So you can now prove that both of them aren't the same. Is that all right? Grant. Now I'm going to show you a little trick with the next one. The next one has a trick, all right? And actually 20 and 21 both technically have a trick. Okay? So I'll obviously do 20, then you'll do 21, right? But look at this. Okay? See the way that's the reverse of this one. Do you know what I mean by the reverse? So example is if I gave you x squared minus 25, the reverse of that is multiplied by minus 1. And it reverses into 25 minus x squared. Does that make sense? One of them's the minus 1 version of the other. Is that right? So what I'm thinking is this. I'm thinking about grabbing that 16x over. I'm thinking about grabbing that minus 16x. The minus belongs to the 16. All right. And here's what I'm going to do. I'm going to multiply. Do you remember what I said about fractions? For example, 2 over 3. I'm allowed to multiply the top and bottom by any number of my choosing, provided I use the same number. Okay, so in this case, I'm actually going to multiply. So if I multiply the top and bottom by 4, that'd be 8 over 12. Would you agree with that? Which is still 2 over 3. So in this case, I'm using that same logic from first year maths. And what I'm saying is, what I'm going to do instead is I'm going to do minus 1 on top and minus 1 on the bottom. And look how it affects it. What's minus 1 multiplied by this? X squared minus 16. All right. And then what's minus 1 multiplied by minus 16x? Yeah, and that's the trick. If you see that trick, you're in business. And if you don't see that trick, it's a much more difficult path that you do not want to go down. Okay. Now, are all of these fully factorized? Not even close. Interesting thing here. Yeah. Are the denominators currently the same? The denominators are the same. What does that mean? I can just add the numerators, can't I? So it's going to be x squared plus 8x, yeah? And so because minus 8x plus 16x is 8x and plus 16. Now, what we're going to do here is we're going to factorize the top and the bottom. Okay? Anybody know how to factorize this one? I need two numbers that multiply to give you 16, but add to give you 8. So everybody's happy with 4 and 4. Now, what about the bottom? Difference of 2. And what will cancel? Anything exactly the same. And what does that leave as my answer? Am I allowed to cancel anything there? They're not exactly the same, so I can't do that. All right. So once again, here's what I'm gonna. Here's this scenario I'm gonna set up. Can you pick a value for x for me? Just pick a value, and you just a reason something like anything 5 and above. 7. Grand, perfect. Right now, look what happens if I replace the number with 7. See, you guys are trying to figure out: can I cut the 4? Can I cut the x? Or you're trying to figure that out, aren't you? But here's what I suggest: pick a number to replace x with. You chose 7. All right. So here's what I'm looking at: 7 plus 4, 7 minus 4. And I go, well, that's 11 over 3 all day long. Would you agree with that? Now, what happens if I cancel the 7s? What does that turn it into? It'd be 1, wouldn't it? It'd be 1s. And does it still equal 11 over 3? Not even close. Means you're not allowed to do it. Does that make sense? All right. And could you cancel the minus 4s? They're not being multiplied, are they? the 4 is being added to the x and the minus 4 is being taken away. There's no multiplication there, which means you're not striking off anything. That's your answer. You're stuck there. Yes. No, no. It has to be multiplied by 7, not whereas minus or plus doesn't matter. Huh? Okay. Sorry, lads. Just to expand on my point here. Right? Ready? Okay. 5 multiplied by 3 multiplied by 5 over 2. Would everybody agree that's 15 over 10? And would everybody therefore agree it's still 3 over 2? Because we just cross off those 5s. All right? But if I have 5 plus 3 and 5 plus 2, would everybody agree that's 8 over 7? Unarguably 8 over 7. And if I cross off those 5s, it's no longer 8 over 7. That's why you're allowed cross off multiplication, but you're clearly not allowed cross off addition. Is that all right? That's the best I can do for you. Right? Yes. Numerator is the top number, denominator is the bottom number. Numerator is above the line, denominator is below the line. All right, guys, you guys try 21, but I want you to try that minus 1 trick on the second part. You see one of them's the minus 1 version of the other one. Okay? I was asked a question, all right? The question was, if I have 1 minus x, gents, I was asked a question, if I have 1 minus x, can I just not swap them around and just say that's x minus 1? Now, here's the reason why you can't. What's 2 minus 5? It's minus 3. And if I swap the 5 and the 2 around, is it still minus 3? No, it's 3. Therefore, you cannot subtraction. Subtraction can't be changed around. That minus belongs to the x. Doesn't belong to any other number there, okay? So you might have remembered back in the day when you did fractions for the first time, right? And when you're adding fractions together, so I'll give you something really, really basic as an example, right? If I had a tenth plus 3/5, okay? And if you weren't to use a calculator, here's what you would do. You would go, I want to change 5 into 10. I'm allowed to multiply the bottom by 2. Only if I multiply the top by 2. And you get 1/10 plus 6/10, which is 7/10. The general rule that you guys learned in first year was that you're allowed to multiply any fraction by the same number, top and bottom, and it doesn't affect anything. It's the same value. Okay? So this carries true to this day, where you multiply this one by minus 1 top and bottom. Now you have a choice, lads. You don't have to multiply the second fraction by minus 1. Somebody else could have came along and multiplied the first fraction by minus 1 instead. It's an either or, right? And I'll show you that both results come out the same in a second. Right, so let's do this one first. See that minus? Who does it belong to? X. So it's 2x, x minus 1. Then it's going to be minus times minus. And then what are we saying the minus 1 does to this bottom? So you change the minus x to plus x, and you change the plus 1 to minus 1. And what's our answer? All right. Now, save that answer, right? 3x over x minus 1. Right? That's a grand old answer, right? Now, what somebody else comes along instead, and they said, no, I didn't do the first one. I didn't do the second one. I did the first one. I go, no bother. It's the same answer, right? So here's what we do instead. They come along, and we do it the blue way. Minus 1 by minus 1. What's minus 1 times 2x? Okay. And what's minus 1 times this? 1 minus x. And then that's minus x on top, and still 1 minus x. What's the answer this time? Minus 3x and? Question. Are the two answers the same? Okay. Interesting. Now, what I'm going to ask you guys is this. Okay. Yeah, I'll show you something now, right? Minus 5 over 2. See minus 5 over 2? If I multiply the top and bottom by minus 1, what does that change to? 5 over. And if you check that in your calculator, minus 5 over 2. Yeah, thanks. Minus 5 over 2, right? That's minus 5 over 2. And it doesn't matter if I put it on the top or the bottom. You'll find that they're both identical. Same answer, no matter which way I did it. So I'm asking you to do the same trick here. Multiply this result by minus 1 top and bottom. And what does it turn into? They're the same thing, just written slightly differently. Okay, so sometimes you'll have the correct answer in the back of the book, but you'll have the minus 1 version of it, if you get what I'm saying. If you multiply top and bottom by minus 1, it's the same thing. Yes.